Hey there, welcome to my channel, and today we're going to consider the foundations of the probability theory. We're starting out our journey by understanding what makes an experiment random, what the experiment is, and other crucial concepts. Oops, I forgot to turn on the recording, I guess. Let me do this right now. Alright, so let's start with something we all know, scientific experiments. And in the typical scientific experiment, we could control all the variables carefully. So, for example, if we try to mix the baking soda with vinegar, the reaction is predictable because we can control all the important factors. We know the chemical compounds being involved there, we know how the experiment will probably result, and we can control the environment of our experiment. So that sounds fair. But here where it gets interesting. Some experiments are different, and that might sound a bit abstract, but think about tossing a coin or tossing a die. We call these experiments random experiments. Even when we try to keep everything the same, the results can vary. Let me show you 3 classic examples. So the first classic example, which you might have already heard of, it's tossing a coin. It's the most obvious and the most basic example which you can encounter in the real life. When we toss a coin, we can get either heads or tails. Even if we try to flip it exactly the same way each time, we can predict which it will be. Mathematically, we write this set as heads or tails. So this is the set of possible outcomes. We can also express them using numbers. We can say that head is 0 and tail is 1, or the opposite, it doesn't matter. So the thing is that we have a set of possible outcomes. We'll later call this as a sample set, but for now we just need to keep in mind that we have some random experiments where we cannot predict the possible outcome. And this is really interesting why we can predict the possible outcome. The reason because in most cases, we just don't have access to all the environmental variables. We're not capable to predict the underlying quantum structures. We cannot resolve the quantum uncertainty. We cannot predict the air pressure or the wind or some other factors. There are plenty of them, and to answer definitively if the coin come up with the heads or tails, we need to know all these factors. We simply cannot do this. So this is why that's the random experiment. Of course, the more knowledge we have, this is called added knowledge, the more accurate our expectations will be. But for now, let's just keep in mind that some random experiments, these are just the experiments where we cannot definitively say the possible outcome which we might have. And the second example is rolling a die. Rolling a die gives us one of 6 possible numbers. 1, 2, 3, 4, 5, 6, obviously. And it is convenient to use the set of possible outcomes like 1, 2, 3, 4, 5, and 6 here. Awesome. So that's a pretty simple example, but let's consider something slightly more complex. Tossing a coin twice. We could get 2 heads, both heads, then tails, tails and heads, or both tails. And that's essentially the set of possible outcomes, which is heads and heads, both heads, tails and head and tail. Oops, I didn't need a comma here. Head and tail. It's just a bit abstract example. So now this is just a set of possible outcomes, which gives you different events. We're going to talk about the events and the sample space in future videos, so don't bother about this too much now. So concluding this video, the key thing here is the control. In regular experiment, we could control the variables of our environment to get consistent results. But in random experiment, as in our examples with coins or rolling a die, there are always factors we cannot control or even measure precisely, leading to different outcomes each time. In our next videos, we'll build on this to understand something which is called a sample space and all the possible outcomes of these random experiments. We're going to talk about what event is and what a sample space is, and we're going to go over the main theorems which exist in probability and statistics. So thank you for watching this video. I hope you found this helpful, and don't forget to subscribe to the channel or leave comments if you have any questions. Thank you. See you in the next video.